Hi, I am Assistant Professor or rather Lecturer Dr. Shah, and I will be trying to discuss some things regarding the geological nature of which we are going to find out in your semesters. And mostly we have known that geology is the study of geos and logos, that is special knowledge about the earth system, or rather in many countries it is taken as a unit in planetary science nowadays. Now the planetary science or evolution of the planet, actually it deals with several aspects like its crust or its ocean or its mantle if it has a mantle, or its core, etc., etc. The beauty of the earth is that after its formation its core is active and core is still moving inside the earth, and earth can be divided into different parts, like the upper fraction is known as the crust, then the lower part of it, the crust, it is known as the mantle, and the deeper part is known as the core. It is crust. This fraction, the crustal fraction, can be seen or can be observed to be stretching or having a depth of around from 20 or 25 kilometers to even at about 80 kilometers. And the mantle also stretches, and the stretch of the mantle is much more enough in the kilometer scale than the crust. Crust is actually, it is, if we try to compare it with some milk pot in an oven, then the crust is actually the upper parts of that milk pot when the milk is getting warmed up, and it is the upper thicker cream part that the crust can be compared with. Then the mantle and the core can again be divided into different parts, like lower inner core, outer core. Mantle can be subdivided into two different parts, that is upper mantle, lower mantle, and the crust. And the crust mantle transition zones of the crust sometimes is also known as lithospheric part of the plate, and the more deeper part of the crust in the mantle transition, it can be known as the xenospheric part of the crust. Now obviously these things like crust, mantle and core it is not well, or some of the other planetary bodies they don't have these types of definite fractions of differentiated, or they can be observed as differentiated as the earth is into different parts like crust, mantle, core, etc., etc. Some of the planets, they don't have even dissolved core or some liquid core, which because of the mobility might give rise to magnetic field. But the earth, because of its uniqueness, it shows the development of the magnetic field because of some liquid outer core and its movement and its dynamical or electrodynamical behavior. Okay, so the thing is that the earth came into existence at around, suppose it 4.5 billion years ago. However, the universe came into existence about 14 billion years ago throughout an event of Big Bang. If you can observe my channel, you will see that there is a video which is known as the origin of the universe and then its evolution towards Earth. You will find out how the universe was created. And obviously 14 billion years ago, if I observe that there is a Big Bang, then after the Big Bang for some milliseconds there were actually no light, and there was a dim haloic nature of the radiation in the universe, and these lights, or during the time of their genesis, the lights are still reaching above, or which we can see through the usage of the telescopes like Hubble Space Telescope and other telescopes which we have found out, or which we use for the usage of that. Now the question is that if we are residing in a galaxy, like suppose it is our galaxy which is known as the Milky Way, and there is another galaxy which is known as Andromeda, then Andromeda and Milky Way, they are, quite frankly, they are coming at each other, and within like 4 billion years or something, some of the time like that, there will be a change, or there will be so during in most of the cases, on the other hand, the galaxies sometimes they also shift away from each other, and we can find it out from an effect which is known as probably Doppler effect. Please try to observe that, and this phenomenon is known as a redshift. In case of redshifts, whenever the galaxies, or whenever they are trying to get away from each other, then what happens, the light wave or the wavelength of the light is getting stretched. But in case they are coming at each other, then the wavelengths are getting much more smaller. And we know that as the wavelength of the blue end of the spectrum is much smaller than the red end of the spectrum, then naturally in this case, whenever two galaxies are moving away from each other, the lights will move, or the spectrum of the light will move to the red end of the spectrum, and which event, and this event is known as a redshift. And obviously it is going the redshift, so obviously the universe is expanding. That is a pretty, I mean, simplified notion, expanding. From the perspective of thermodynamics, we have probably you have read in physics that the entropy of every single substances in the universe is increasing to create a much stable configuration for the universe. And throughout the 14 million years of time, first element which was present, which was hydrogen, as well as the hydrogen then transferred itself into deuterium and then helium. And what happened, because of the generation of this hydrogen, deuterium and helium, there were some of the centers of the universe had some gravitational collapsing possibility, where some of the centers, or the galactic centers, became epicenters for generation of large or new stars. Okay, and those are practically the earliest stars. Those are practically the earliest stars or star systems which we might observe nowadays, because we know that the light takes a light year to travel a distance in a year, and the more older the light rays are coming out of the galactic system, the more we are getting the information of that time, because light is traveling from that time to this point, or through the to the telescopes of the Earth, and we can analyze the elements or whichever was there. And most of the astronomers do these remote sensing pattern or remote sensing technique. Now, if the 14 million years ago, after the Big Bang process, obviously there was generation of the elements like hydrogen, helium and lithium, etc., etc. The new stellar cores which were formed by carbon, nitrogen, oxygen cycle, and the first generation of the stars formed, and because of some processes like P process, that is rapid neutron capture process or slow neutron capture process, more heavier elements were generated like hafnium, tungsten, etc., etc. The beauty of the sun is that, or the solar system is that, solar system, in spite of the fact that the solar system, if it has originated 4.5 billion years ago, but still we might find some of these heavier elements which, or their isotopes, which are not even possible to get differentiated or get generated in the solar system. So obviously there was some part or fraction of the earlier or pre-existing stellar cores which might come in the solar system by some supernova explosion. Supernova explosions are nothing but whenever a star is massive enough that there are some of the fuels which can burn it from the outside, but inside of the star that is not much more stable because of the lower radiation pressure. Because of why? Because of the fusion is no more capable to be creating that amount of energy that can resist the gravitational collapse, and then the shell of the stars or the star gets destroyed by an explosion, and this explosion can give away all of the heavier elements or even generate some of the heavier elements because of these shock waves. And when these shock waves generate these heavier elements, those heavier elements can be incorporated in the new system, suppose in case of our solar system, and that's why some of the elements were actually star dust. Okay, so that is how the primitive stages of the solar system was. However, the solar system or the generation of the solar system was much late, at about 4.5 billion years ago, when the solar nebula or the pre-existing or proto-sun was in existence, or it was just in a proto-scale, and there was a solar nebula. The nebula got itself accreted by some gravitational collapse, as well as because of the gravitational collapse, all of the elements or all of the minerals or whatever the rock fragments they were becoming accreted with each other. Suppose smaller fractions of rocks or particles are there and they are in a motion of hydrodynamics around a proto-sun. Okay, and certainly they will be colliding with each other, doom dum, they are colliding with each other, and there is some amount of heat energy that can be generated, and that heat energy can be used or can create some melts or melting in this system. Now, melting is a big phenomenon. It can be partial melting or not even a partial melting, and around this proto-sun these things are happening, as well as the gaseous matters which were in the system, they are trying to escape out of the system because of they are much more potent in terms of the energy to escape the system because they are lower molecular mass. Okay, and those gaseous matters, whenever they were escaping the system, they formed the outer planets, and the rocky masses which were colliding with each other, forming rocks and much more larger things, those formed the inner planets like Mercury, Earth, Mars, etc., etc. However, the Saturn or Jupiter or even Neptune or Pluto is not even a planet, and they were actually the gaseous planets, and because of these things, there was a uniqueness in Earth, that Earth was formed as a rocky planet. Then this rocky planet evolved throughout time by the addition or subtraction of volatile matters or water, by infinitesimally some of the impacts were there. One impact is known as a giant impact, and then there was evolution of life by the presence of water, or water and life itself produced different set of minerals inside the rock, and that's when the Earth was evolving. The primary period of the Earth is known as Hadean, then it was followed by Archean. Earth was formed at around 4.5 billion years ago, and then it was Hadean times. The Earth was much more warmer, and there were no stable crust which we may observe today. The tectonics were mostly plume and plate tectonics. I hope other teachers have discussed regarding what is plate tectonics is. The plate tectonics, it's nothing but the motion of the crustal plates like oceanic crust or continental crust over the mantle depths or flow of the lithosphere over the asthenospheric boundary, and they can generate different types of tectonic setups like mid-oceanic ridge, like what you say, that a subduction zone. Sometimes they give rise to basaltic magmatisms, like in case of Siberian flat basalt or Plateau or the Deccan traps, etc., etc. The thing is that the Earth system had evolved as a continuous or continuum of a heat engine and still continues to do so by radiating the heat it has in its center or core by advection, conduction, as well as convection. And we are seeing the evolution when water was added up or even was present since 4.4 billion years ago. The question those we should ask now: how did we find that there was water 4.4 billion years ago? How did we date the age of Earth, as well as if there were planetesimal impacts? Is there anything that we may know from the shooting stars, or rather the meteors or meteorites or comets? These should be your questions. So, apart from that, there are some parts of the ocean circulation, the engine that is modified by the incoming solar radiation. I hope you guys have seen the movie called 2012, and where the scientists were saying because of the radiation, some of the neutrino enhancement, there was some melting below the crust and then it moved like in a 7-day. But if that kind of cataclysm happens, it is quite sanguine that no one will survive, because the things will go much more destructively, because the gravity field will be changing in a much more rapid fashion. It is more of a like situation of a man of steel. And we have seen that the terraforming is happening, and then boom, 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 and then there was a change in the atmosphere, there is a change in the gravitational field, etc., etc. So that was a big thing. It was shown in the small screen. So that is how the Earth actually works. It works in terms of the heat energy as well as the mechanical aspects, controlled by the minerals and rocks involved in this whole scenario. Now, this is very important, that minerals and rocks are important to observe and understand how those are, affecting the planetary things or whatever it is. Now, what is the definition of a mineral? And what is the definition of a rock? Minerals have a lattice, has a chemical composition. It should be naturally occurring. Composite or substance with a definite crystallographic orientation or something like that. Rocks, these are nothing but aggregates of minerals. Even clay or mud we play with, those are also small particles of the minerals. Ice is actually a rock. Halite is a mineral, or the salt we eat, it's a mineral. So there is a strong dependency of these minerals as well as mineralogical transfers, as well as the activity of the water or other fluids like CO2. They actually determine how the earth system works, and over it there is a sense of ecology or the ecosystem, how it interacts with them, and they kind of totally determine how we see the earth system today. But first of all, we will have to understand about the meteorite, which I was trying to tell, that meteorites hold many type of keys regarding the chemistry or even the evolution of the solar system or even the earth. The meteorites can be defined into two different types, that is, one is iron meteorite and one is stony meteorite, and another is known as stony iron meteorite. The difference in between them is that some of them had undergone severe amount of melting. That's why some of the retained core that contains high amount of iron or metals in it, which are known as iron meteorite. Stony meteorites, on the other hand, had undergone very low degree of melting, and most of them are chondritic in nature, and this is the most important building block of the reservoir of Earth. By reservoir, I don't mean that is a water reservoir, but by reservoir I mean the reservoir is distinct in terms of its chemistry, that is composition or concentration of different types of oxides or silicates or even sulfides, etc., etc. Please try to go through the lectures, as well as try to observe a book which I think it is of Lunine. Try to go with them and then